Hey everybody, welcome back to the Lennon Stand. I'm Lennon, and as it is our school holidays, we are doing a very special show in the themes of bloom and blossom. Now we have all this beautiful color around us, from our flowers to our trees to even our human creations, our beautiful cars. But we have a beautiful color that looms above us every day, no matter what, and it is our beautiful blue sky. So today's themes are going to be asking the question of, why is the sky blue? So as we'll be asking this question, we're going to need to figure out what passes through the sky, which is of course light. So we're going to look at the properties of light so we can try to figure out why the sky is blue. So today we have 3 experiments planned, 2 physical experiments and 1 thought experiment. Our very first experiment is all about refraction, that I have our experiment prepared just here, which simply we can very easily do at home, where I have a chopstick that's put inside a glass cup that is filled with water. Now what's happening here is refraction. And the refraction is simply the bending of light. So we have here, our chopstick goes in very straight coming in and seems to bend as it crosses the surface level of the water. But as we pull our chopstick out, that's not the case at all. It's just simply a very straight chopstick that's bent from as the water enters it. So what's actually happening, that as the light comes along as waves and hits the water, different little bits of the light enter the water at a different time. So we have the light slowing down and then beginning to have this bending-like shape that we see. So that is why our chopstick looks bent. So we're going to employ some of my brilliant drawing skills today and see if we can sketch exactly what's happening there. So we have our cup that's full of water, and we have our chopstick that's sitting inside our cup. Now we have our light that travels along and eventually hits our water, but as the light is still entering it, some of our little bits of light has already been in it. So they begin to bend a little bit. So it continues entering in a bit more and a bit more as the light slowly bends more and more and more until it comes back out the way it entered. So that is what we call refraction. Now it can do some very amazing things with refraction because it refracts through every medium. So when we say medium, it talks about what our light is passing through and what object it is in within it. So here we are in the medium of air. Our cup here is in the medium of water, and we have a prism just over here set up over at the wall that is in the medium of glass. So this is a glass prism, and from the shape of it we can do some very amazing things. And as it's brilliantly sunny at the moment, and if I can angle our prism at the right angle, we should be able to see. So here, now we're outside where it's nice and sunny here at Discovery, and we have our prism working properly so we can just see the perfect dispersion of light. That is, the sunlight enters perfectly through the top of the prism and refracting inside the prism as it slows down through the medium, and then disperses our different colors of light onto the ground. So we can see our beautiful rainbow-like color. The actually exact same happens when we have our raindrops in the sky creating our beautiful rainbows, just on a beautiful sunshine after we've had a lot of rain. So now that we're back inside after having a look at our prism dispersing light, we're now back to our drawing board as we're going to sketch it. So, what we saw before was our prism, our triangle here in the middle, and we had our incident light from the sun coming in from the sky, and as it enters our prism, just like we saw before in our cup of water, we saw a refraction of light as the different strands of light begin to stretch and bend through the glass. And we see them exit in different colors, all after separating the different wavelengths of light throughout our prism. So just like a rainbow, we have the red up the top as it gets a little bit darker to a green, and then gets all the way down to our beautiful blue color. And just like this, and our three-colored rainbow, we can see how a prism disperses white light into every color of our rainbow. So what would happen if we were to block out one of these colors? If I hold my thumb over top of the blue, well then clearly our white light will then only be dispersing the red and the green and all the colors in between it. So if we then think about this, about how it applies to our sky, where our sky doesn't really seem to be blocking out all the blue, because we still see blue objects around us from when they reflect blue. Maybe we need to draw some more diagrams. So I'll throw my other pens away, and I'll keep our last blue one. So we're going to draw our atmosphere. We're going to draw it very simply, a whole bunch of dots in the sky. Now we have our sun up the top here, who's very cool with some glasses. And our sun shoots down rays of light that come through. So we have our blue and then other strands of light. Now our air particles, they absolutely love to absorb and scatter small wavelengths of light. That is our blue. So when our blue collides with our air particles, it scatters them around. So we have the light traveling down without any of the blue light. But that doesn't make sense, as I said before, that we can still see blue light all around us. So a lot of the light from our sun is still making it through past our atmosphere, but some of the light is scattered. Now this light that we see scattered stays up in the sky and eventually will come back down after being dispersed between the different particles, and then we see that as our light. This has its own technical name as Rayleigh scattering. So, discovered by Sir Rayleigh back in about the 1800s. He discovered the scattering of light dependent on the wavelengths of our lights. Now we may ask ourselves, what exactly happens when, say, the sun is to get a little bit shallower in the sky? Well, then we have our sun move down to a much more of a shallow angle. So we see the sun set behind the horizon, and the sun will then travel through much more of the atmosphere, then absorbing and scattering much more blue light, eventually barely even allowing any blue light to come through at all, so then we see mostly red. And that is why our sunsets begin to be red. Now, if we then think about how beautiful this is on Earth, maybe then we have to start to try to think about what are the colors on different planets in their skies and in their sunsets. So in the first picture here, I have from our Russian friends the Veneer 9 probe, a picture from the surface of Venus, and we see a very yellow sky from the sulfuric acid in the atmosphere and from the large concentration of greenhouse gases. Now we have our Martian sky, taken by the Curiosity rover, which is mostly carbon dioxide in the atmosphere, but with a very low concentration of it. So that's why we see it to be somewhat a bit red. And if we also think about how when we had heaps of dust particles in the sky, they also like to scatter a lot of blue light. So that's why we see our skies to be red if we're sometimes around fire season with a lot of smoke. So with this, we reach the end of our show today. I hope we've all had a lot of fun answering our question about why the sky is blue. And I hope we've all learnt a little bit about how light works, a little bit about its wave nature, how we can draw it like this, a bit about its dispersion and all the colours inside the light, and how we have Rayleigh scattering from our light through our sky. I hope we all have a wonderful rest of our school holidays, and I hope we have a wonderful rest of our weekend. Thank you very much, and I can't wait to see you all next week. Bye!